All right. Hey, everyone. Welcome to another deep dive. Today I have with me Suning from
Yes,
HyperOracle.
hyperlocal.
Yeah, great to meet you. Um, just wondering, first off, how did you kind of get into the space and more specifically doing Oracle bridge type things?
Yes. So initially how I got to blockchain because I did an internship at UnionPay, so which they are like a Chinese version of Visa, and I got a chance to work for them uh, after my freshman year in college, and that was 2 years ago. So then they have a blockchain team, but mostly they are just doing permissioned blockchain for for the companies or something like that. And then I know about Ethereum and all these public blockchains. So I like did another intern at one of the crypto VC called Foresight Ventures in
Oh,
my
yeah.
sophomore year. And then um, I also did another intern at Google after my sophomore year. Then I met all the other co-founders of HyperOracle, and we think why not we just start our own project, and also using the new technology of ZK, and that's how we get started with HyperOracle.
Cool. Yeah, so I mean, this is, like you guys are an Oracle, but like sort of a reverse Oracle, right? Um,
Yes, yes, yeah, that's right. Actually, like the original name for our protocol is called the ZK Graph because we want to build the ZK version of the Graph protocol. But then we think that our application can be extend more than just doing the indexing functions of the Graph protocol because we have a general runtime for our all these programs, all these off-chain programs. So we think that for all those computations that run in off-chain, we can actually add in the ZK to it. So that's why we changed our name from ZK Graph to HyperOracle. And for Oracle, we actually have a kind of slightly different definition for it because like traditionally, if people think about Oracle, they will think about channeling price feed, those type of Oracle, and those type of Oracle is actually input Oracle because you are inputting the data from off-chain to the blockchain. So that's why they are kind of like an input Oracle. And for the output Oracle, one example is the Graph protocol and also our HyperOracle's ZK indexing. So it's basically outputting the data from blockchain to the off-chain and maybe do some complex computation in the off-chain, then the data or the computation result will be used by the developers. So this is kind of how we are doing the things in reverse. And also we are defining another type of Oracle called IO Oracle. So IO Oracle is kind of combining the output Oracle and also the input Oracle. So what it does is it does the output first. So it first index all the data to the off-chain, then do some like actual computation. Then if some condition is triggered, the off-chain computation result will be sent back to the on-chain. So this is very much like an automation network. For example, like Gelato network
yep.
or Chainlink automation. This is kind of the IO Oracle we are having.
Super cool. Yeah, well, we can kind of get in. I mean, do you guys claim, like, are you guys trying to be really decentralized? What sort of the target? Because the Graph protocol, they started out very, very centralized, and then they moved sort of into this more pseudo decentralized state that they're in now. Do you guys see a similar path going for you guys, or is it, are you trying something different?
Yes, of course, of course. So actually, like we need to like define what decentralization is because
Sure.
maybe decentralization includes like like you need to have a lot of nodes around the world, or you will need to have a very low hardware requirement for running a node, and maybe you also require some of the security and also the trust minimized properties of the whole network. So one benefit of using ZK into the system is that you actually only need one node for the minimum to like achieve the security and also the computation validity of the whole network. So this is kind of achieving the ZK the decentralization part of it. But also we do need like all the nodes to be around the world to make sure the whole system is alive when like the server crashes or something like that. And
Right.
also can be like boosted by ZK because if you think about a traditional network, you need to like have multiple nodes to make sure something is correct or the computation is done correctly. And these are all done by re-execution. And if you have ZK, you can actually have only one party that eventually gets the output and also the proof. And then if someone have the output and the proof, uh, this can be like 100% accurate because it is proven by math and cryptography. So for this, we can actually have like a single point of truth from just one node. And maybe for each country, we can have one node so that the service provided by the node can be like much better because the node is actually closer to like the requester of those data. So that's how we value decentralization.
Cool. Well, yeah, well, let's jump into it and we'll kind of see how it actually works. First off, what would be a good example of a piece of data that you would want to bring on chain? So like let's say I'm guessing, you guys would probably do Ethereum,
Yeah,
right?
sure.
So, like we will have some smart contract here. What would it be like? Some token contract, and then, or what would be an example of something that people would come to your service to use?
Yeah, maybe like the most data they want to use is the event data because it is not like directly stored on chain. And also you need an indexer to get all those event data.
Okay, so I mean, like we use the graph protocol. Maybe you can walk us through this example. So like we have the teller oracle, which is another similar, like for this purpose we'll call it, like let's say, a chain link price feed. It throws
Yeah,
data on chain and it spits out an event of basically like the price of BTC USD, say, and then there's also like who submitter and like the timestamp,
yeah,
and then it spits it out. So this event is happening every few minutes on top of Ethereum. What you guys would then do is, I guess, grab that event, right? Or you would
yeah,
have, where should we
yes,
start? You have this network over here of nodes, right?
yeah.
Okay. So these nodes, I guess we can start here. Well, what do you call them, by the way? Or
We are like
just
right now
nodes?
we don't have a name, but just call it hierarchical node or something like that.
Okay.
We don't have a special name for that.
Hypernodes.
But
Um, okay, and so do you have to stake to become a node? Like, who are these guys? Or is this
uh,
just,
no,
you
we don't
guys?
actually have to stay because we use ZK. So it's another kind of the advantage because if you are like staking to enter the system, um, actually the stake that you uh, like stake into the system cannot measure how like profitable to hack this data or something. So
Sure.
like the recent example is that some of the MVB bots are hacked on Ethereum because there's some bug in the Flashbot client they are running, and like the profit of this hack is about 20 million, but actually like the slash happening on the Ethereum network itself is only 2K. So this like measures like how the unalignment is happening in the system. So and also like we think that in the middleware network, if you want to stake and because the business model of a basic blockchain network and middleware network is actually kind of different. Because in the middleware network, what the network need is just provide the accurate data. But for a blockchain network, what they need is to prevent computation platform. So these two are different, but like the business model of middleware network is actually um, like have more restrictions and also like higher bars for the security. So that's why we think that using ZK to replace staking, this kind of economic model is much better because we are more relying on just math and like just code, kind of
Well,
like that.
sure, but I mean, like, could I become one of these nodes?
Yeah, of course.
So you just basically download the client and spin it up, right?
Yeah, kind of like that.
Anybody can do it, and there's not really. Do you have to be whitelisted or anything?
Yeah, eventually it will, yeah, be like fully permissionless.
Okay, so currently you got to get whitelisted, and then in the future, there's nothing preventing it from just being open up, right?
Yes, that's right.
Okay. And then I guess so these are the nodes, and then we'll have kind of our output over here.
Yep.
Um, this is like what our website, right? Or the
Yeah,
user.
website.
Yeah, so like, in this example of Teller, like, we grab the event data and then you can see it nicely formatted on our website.
Yeah,
Um, okay, so what do these know? What is the ZK magic here?
yeah.
That you would grab it, and then I'm guessing there would be some sort of ZK proof contract. Is this did you guys like write this in, is this like Circom or some similar ZK library, or is this all custom stuff that you guys have done?
Yeah, so for this ZK proof, it's actually living inside of the nodes. So
Okay,
this is not like a smart contract on the blockchain. And
so this is inside. Okay.
yes,
Inside the node.
yeah.
Okay. And then they grab that event data, and then I'm guessing each of these guys is running a Ethereum node, right?
Yes. But they actually don't have to because uh like we have a lot of different parts for this ZK proof.
Sure.
And so you can of course directly run a Ethereum like node to get all those block header or get all those event data or something like that. But also you can like run kind of a light client that
Oh,
verifies
sure.
some kind of ZK proof, and then you can get the correct block header and something like that. And we are doing this by a new like a snark like client called ZKPoS. So ZKPoS is basically proving the Ethereum consensus with ZK. And uh,
So
one
how
of
does that work though? So
yeah,
you
so
would grab, you're grabbing the event, but you're also grabbing like basically you're grabbing like a whole Ethereum state, and then you're proving that this event is within it, I guess.
yes, so ZKPoS is kind of the step that is before we do all the computation with the event data. Because
So
we need to get the block header first, then get all the three roots, and then we go into the roots and get the actual event data.
okay. So
Yes.
so you would get this ZKPoS is
For
basically
the block header.
block header, right?
Yes.
And then that validates that the block header is valid, right?
Yes. Through ZKP.
And then what does it validate that it's valid against? Like, you know, against the light client that you're running, I guess.
Uh,
Because, you know, like what would prevent somebody, you know, you guys from saying like in your own light client, like forking it, doing some event, and then submitting it saying like, look, it happened, you know.
so for this ZKPoS or this kind of block header, it will also be verified in the client side. So like in the
Oh,
website, you can also verify it.
so
So
the
that's how
website
you
would
get.
also have its own node, and it would verify that the block header that you used is a valid block, for instance.
Yes, so that's why uh,
Yep.
how all the pipeline can be like have a kind of consensus over some root data. And for the website, it actually doesn't have to kind of have a node or something. It just need to have a kind of verifier library, maybe written in JavaScript or something like that to run the verification. And then it will know the ZK proof is correct. Then all the computation is correct. And then finally, it can know that the block header is correct.
Well, it would need probably some inferior connection or something, so it knows that you guys didn't fork it, right? So it knows that this node didn't like fork the whole state of Ethereum, do
Oh,
some
yeah,
action and give
yeah,
you an invalid proof. It would have to verify that, right?
yeah, that's right. So
Yeah.
like you can actually also kind of uh, like prove that proof generate all the proofs for the fork or something like that
Yep.
because yeah, but actually right now what we are doing is that we are trying to like getting the RPC and we wrap the ZK around it, wrap all the ZK around the like the consensus we are having right now, and then just making it smaller and better to be verified. So that because if you are adding ZK, um, like multiple blocks can be uh, just generated into one single proof. So maybe you have 100 blocks. If you do it the traditional way, you have to go through all those 100 blocks, and it's maybe
Okay, so you guys would
much
batch all the
faster.
events.
Yeah.
Oh,
That's right.
cool. Yeah, nice. Nice. And then, okay, cool. And then, so you batch the events, you put them in here, you verify that the block header that those events are in the given blocks, and then you pass those events over with a proof, and then they would be able to check, oh, it was a valid block. These are the events, right? You would know
Yes,
for
and
certain.
yes, that's right. So this contents is actually related to the block header and the roots, and these are kind of the fixed logic inside the ZK proof we are having, and then we do have the customized logic for the event data. So it's kind of like we are also having the concept of subgraph in our network.
So what does that mean?
So it is called ZK graph in our network, and it is essentially how the developers are using this our services can define all those handling of the event data for maybe indexing or automation with in a programmable way. And this is like we are having the fixed logic for the block header and the roots. And for how to handle the event data, the developer can write some JavaScript code or
Oh, so it's like,
like
yeah, JavaScript code to parse it, right?
yeah, kind of like that. It actually defines how the event data will be stored in
Yep.
the storage. And also in automation's case, it will also define how we are like sending the data in the upstream to the smart contract for the automation. And it also defines the trigger condition. So when the process of inputting the data onto the smart contract happens.
Oh, so this would be like, we can write another event. So like this would be, say like, a Uniswap contract here. And then you could have it written like, if this price event changes in a certain amount, then it goes over here. And then you guys would run whatever JavaScript code they had here. Likely it would be make a trade on Uniswap because it's profitable. Could be an example,
Yeah,
right?
yeah, that's right. Kind of like that. And also this part is uh, inside the ZK proof actually, because we will generate all the ZK proofs for that.
So you would generate a ZK proof so this JavaScript code gets put into the ZK proof.
Yes, yes.
Oh, cool. Nice. So then when does the event get executed? So like if you had in here in your custom code, okay, we want if we're going to get two prices, the price of, ETH and USDC. If you grab those prices and it's changed and it's profitable to trade on Uniswap, make a trade, right? You would
Yes,
see
yes.
the event and then it gets run by these nodes like instantly.
Yeah, kind of like that. So uh like the two different events, or maybe the events coming from different protocols, maybe they are written in different subgraphs or ZK graphs. So this each of the different subgraph or ZK graph will be forming a kind of sub network of the hyperlocal network. So for the nodes, maybe some of the node is running for the first event, and some of the nodes are running for the second event. So this is kind of having the sub network for each usage or each ZK graph. And this is all running like independently, or maybe more streamlined, because you have this event and coming to all the nodes that are running this job, and then it will eventually be sent to the website or users or something like that.
So it would either be sent to the website or sent back as like an IO oracle where it would go
Yes, yes,
back into a
yes,
smart
that's
contract.
kind of like that.
Yeah, super cool. Um, yeah, and I mean, I guess with the client JS code, like this would be, like if you want to make a Uniswap trade here, like the node would make it. I'm guessing you would have to send along with it. You would have to have, how would they pay for the gas there? Who would be paying for that?
You
Or
mean the
would they just have
user?
to fund the account, similar to like a keeper?
Yeah, yeah, it's kind of like a keeper for the automation. So this is actually like the keeper needs to fund it by who deploys this ZK graph or who like request for this automation service. So this won't be directly funded by the user, but maybe like inside the developers protocol, they will have a premium on the fee for using Hyperlocal or something like that for the user. And actually the cost is maybe you set up like a fee pool for the hyperlocal nodes, and also you set up a verification contract on um, Ethereum network to verify the ZK proof. And these are the two major costs for deploying some services on hyperlocal network. And another key point is like how the JavaScript code can be generated, approved, and also how like running all the code inside of the ZK proof system. And this is also another key part, I think. And
Yeah, I mean, how do
for
you do that? It's just how do you turn JavaScript code into a ZK
yeah, yeah,
proof?
yeah.
You know,
So
is it limited? I guess very limited as far as what you can do in there.
um yeah, in some way it is limited because right now we support assembly script. So assembly script is kind of like a subset of JavaScript, and it is more restricted, a little bit more restricted because you need to like write a lot of types for your variables and something like that. And it's kind of like TypeScript, but I think assembly script is also just JavaScript. And one like magic for assembly script is that it can be compiled to WebAssembly, and WebAssembly is essentially kind of a general runtime for all those programs. And recently, like we see a lot of ZK EVM, right? So ZK EVM is for running all the Solidity code or Viper code. And we also have a lot of general ZK VM that runs all the like traditional programming languages. And one of the general ZK VM is ZK WebAssembly. So any code that you compile into WebAssembly format, it can be run inside this general ZK VM, and you can generate the proof so that the developer don't need to learn like ZK languages like
Nice.
Circom or Cairo, or maybe like learning Halo 2 or something like that. So they just write JavaScript for a new ZK graph, or maybe they can just migrate their subgraph from the graph protocol or Gelato network, so that they can like seamless do the integration from other middleware networks to our hyperlocal network.
Nice. So I mean, then you guys, if this is a snark, so for every piece of client, you know, the client comes and they're like, okay, we have this subgraph and we want it. How do they generate this proof, or do they pass the JavaScript over to you guys? Because I'm guessing these are trusted setups. They would have to be.
Yes, yes. So this proof generation will be done by the nodes of hyperlocal network.
Okay.
So so for the nodes, it's actually having another type called prover. So prover need to have more like high-end hardwares for
Okay, so
generating the.
there's some nodes that do this, but then there's some special nodes, you could say, right?
Yes, yes, some special nodes that maybe only do the proving.
And they're the people that they generate this ZK proof as well.
Yes. Yes.
Okay.
Yeah, they generate the ZK proof.
So like they would take the client's code and they would generate it, and then the other nodes would basically just be validating against that proof, right?
Yes, kind of like that. So the nodes validating those truths is kind of like a like kind. And it actually doesn't need to happen inside the network because maybe sometimes they want to validate them because they want to like do like the further computation on the previous computation. So that's why they want to get the latest state. Then maybe they want to generate the proof itself or do the some kind of execution itself. So this verification can only it actually just need to happen in the end user. So like in the website or in the on-chain smart contract of the
Yep.
automation, uh, you can just verify this ZK proof, and this ZK proof doesn't necessarily need to be verified inside the hyperlocal network because well, why we having the ZK proof at the first place is that we want to convince some party that we done the execution correctly, and the major party that we want to convince is the end user and also the on-chain smart contract, which represents the layer one blockchain of Ethereum, and anything else is uh, not mandatory. Like inside our hyperlocal network, we don't need to convince all those other nodes that we generate the proof correctly. Like because how the KP works is that if you have this, so under the condition that all our code and all our cryptography is correct, you don't need to you cannot generate a bad proof or a dishonest proof. So if anyone has this proof, um, you can just verify it and you will be convinced that they do the computation correctly. And if like they do the wrong calculation, uh, it there will be no proofs generated, and this will just like return a false or something like that.
Well, I mean,
Yeah.
how do you select the prover nodes? You know, or how do you
Yes.
because it seems like if those guys get messed up, the whole network breaks, right?
Um, yeah, it kind of break the whole network because um like if you don't have the ZK proof generated, the end users or the smart contract they cannot verify all
Yep.
those computation you have done. But actually we don't need to have we don't need to like manually select the nodes because it just like if someone want to be a prover node, they can just be the prover node. Because if you can like generate the proof, you can prove that yourself as a prover node is doing the calculation and all those computation correctly. So you don't have to
Well, I
like
mean, how would you verify the setup though? You know, like if you're setting up the original, you know, if you're creating the keys and stuff like that, you know,
oh yeah
who
yeah
does that? That's the prover nodes.
so for this setup, it's actually also called the uh, something ceremony or something like that.
Yep.
So it happens before like the network actually started.
So
So
you don't need to do a separate one for each
yeah,
JavaScript.
we don't have to. Yeah,
Okay.
it's a universal setup for
Okay.
like the whole network.
So then this, when the client inputs JavaScript code, that's just an input into the already created ZK proof file, right?
Yes, kind of like that.
Okay, cool.
Yeah, and eventually we will have a universal verifier contract. So it basically represents that we have a much universal system for all those custom proofs,
Right.
even though that they are different and the execution trace is different. Like when they are combined into a ZK proof, they are actually just like the same format or the same structure. And for this universal setup ceremony, because we are using Halo 2, so it has this kind of universal setup. And yeah, and also like nowadays they also have some like other ZK protocols that doesn't require universal setup. So
Sure.
or any setup in general, and it is called Stark. But for this kind of universal setup, I don't think it's like a big problem if you have a universal setup because like for the KZG ceremony, I think no one will like consider it to be risky or something like that because this universal setup it follows the
This is breaking up. Test, test. No.
big problem because the trust model is very secure, I think.
Cool. I think we
Yeah.
I think we may have broken up for a second there. Um,
Yeah.
but it's okay. Um, no, this is super cool. I think, yeah, like wrapping my head around this piece. Still, it's just, like, how I think I'd probably have to do a deep dive into the code to see how you verify custom JavaScript code within a zero knowledge proof. Um,
Yes.
but I'll believe you on it. It's super cool. Um, validate that it runs properly. I think, the other piece too, is there any token involved or any token kind of planned on the horizon within the system?
Right now we don't have a plan for that. Um, but if we want to like design a whole economic system, I think like taking the graph as an example, I think their approach is that they are adding a lot of economic models into it, like all these creator uh, like creator thing and also some like bounding curve for the like the actual reward you are getting. So I think most like some of the components of um, the network that involves the staking as a key security model, it's actually too complicated for the users to understand because you have a lot of economic like models inside of it. And I think for a ZK system, another advantage of a ZK system is that you can um, like from a macro point of view, you can simplify all those mechanisms and you can remove some of the economic part of it and you replace it with just massing cryptography. And this massing cryptography will not be like shown in the uh, like the general point of view because it is the complexity in the system is actually shifting from the um, whole mechanism into just the circuit code. So this is kind of um, like the general design will be much simpler. And
Well, I don't know if I would say like using zero knowledge proof simplifies things for the users. I feel like they're
Yeah,
still like
yeah,
just in the dark. They're like, yeah, somehow it works,
yeah.
you know?
If you're treating the ZK as a black box, it may
Right.
be much simpler. But if you really want to understand the whole network or something like that, it actually requires much knowledge because like ZK
Yes.
is too hard to understand. You have to understand all the cryptography and you have to understand all the like the proof generation process for like the computation or something like that. So
Nice.
yeah,
And then, oh, last question, or not last question, but where's the fees happen in here? You know, how do these guys get paid, and what's their incentive for doing this?
um, yeah. So right now we don't have a like a fixed plan for that, but I think our model will be uh, kind of like Keeper network. Uh, so
Okay.
it's KEEP and 3R network. So,
Yep.
so that one. So it essentially creates a bounty or something like that for each of the ZK graph. So this bounty is just like a fee pool. And this fee pool will define like how all these computation or jobs will be charged or something like that. And the nodes may directly collect the fee from the bounty. And this is kind of simplifies all those um, like
So
word collection or something like that provided by the graph. But this is still like in the design process, and this is just some experiments that we are trying to do.
yeah, so basically you would fill up a pool, fill, you know, like tons of, let's say a bunch of ether for paying for gas or for rewards, and then the nodes basically they would generate some sort of proof that their address was the one that fulfilled the request, and then they can go and claim the rewards.
Yeah, yeah, yeah.
Yeah,
Exactly.
relatively simple, but no, it makes sense. And then eventually maybe you'll drop a token, and then you can bootstrap
Yeah,
all um, no, that would be cool. And then nice. So what? Okay, so now on to you. What did I miss? What's important that we're missing, or I haven't asked questions about?
maybe you can like draw a part of for the ZK WASM we are having
What's
for the
that? Please explain.
That's the ZK VM that I talk about, the ZK WebAssembly VM. So these are for the custom proofs for the
So like the custom client JS stuff?
yes, that's right.
Okay.
This is
Or
also a key part for our system.
ZK WASM, you call it?
Yes. So WASM is
Yep.
basically
WebAssembly.
WebAssembly, and this is the work that done by our technical partner, and so they so initially like when we started this project and we were called ZK Graph back in the days, and we are thinking about
Back in the day of a year ago, probably.
yeah, and
Right.
we are thinking about like if we want to run all those custom JavaScript code, we need a general ZK VM,
Okay.
and at that time, the only option we have is RISC-0. So they are basically building a
Oh yeah.
ZK RISC-V virtual machine. And but for all those existing subgraphs in the graph protocol, they are all written in assembly script. So if we want to compile those assembly script into the RISC-V instruction sets, it will be pretty hard. We'll need something like LLVM or something like that. And also one of the uh, issue about using RISC-0 is that um, they are using the Stark. So one of the disadvantage of using Stark is that the proof size will be pretty large,
Hmm.
and eventually we want to verify all those ZK proof in smart contract for our ZK automation. So if the Stark proof is too big, then maybe the gas cost for verifying those ZK proof will be too much.
So,
And
yeah.
yeah, and we want to make sure that all of our like security is inherited from Ethereum. So that's why we need to find a snark approach for running all those JavaScript codes. So that's why we eventually select ZKWASM as our runtime.
So, and is that like that's like a full Turing complete machine or state machine, I guess you could say? Similar,
Yes, yes.
right, the whole ZKP. So I mean, so what are you verifying there though? So like in this one, so it would just verify that the code runs without a hiccup, I guess would be uh
Yeah, yes,
that's like
kind
the
of like
ultimate
that.
proof.
Yeah, yeah, yeah. This is actually the same as ZK so
Yep.
ZK is basically making sure all the computation is done correctly and also all the state transition is done correctly. And ZK WASM is doing the same thing.
But I mean, like with the ZK WASM, like you still have to, it's, like you would get in the event data and then it would say like, okay, do these events, like you would get the event of the price of Bitcoin, the price of Ethereum, and then, current price on Uniswap, and then it would say, okay, we validated that that happens, and then it would kick it off to a script that would execute it, right? That it would execute a trade. Because I mean, this couldn't execute a script on Ethereum because Ethereum's not like, it's like more async, right?
Yes, so like for the script, like the actual um smart contract core or something like that is not
Right.
running entirely inside ZKWASM, but ZKWASM runs the indexing part. So it's basically the subgraph of the graph protocol. And this part can be entirely run inside ZKWASM because uh, for
Okay.
the
Yeah.
yeah, because it's essentially the um, like the data transition of a database. So it's basically state transition. And also for a automation, um, you are adding more onto the indexing part, like you want to check the condition. And so it's basically a fancy if statement, and this can
Right.
be run entirely inside the ZKWASM. And then you want to um, set some of the data as the like the call data for your smart contract call. And this part is also part of the ZKWASM.
Okay, so that'll set your call data for you, and then
Yes.
yeah, nice. Um, no, that's super cool. I think. Um, all right. No, anything else? So yeah, so okay, so yeah, I mean, I guess we have like 10 minutes, I can start sharing what's kind of I know you had kind of been talking about it throughout the entire piece, but what's kind of the next steps for you guys? Where do you see this going? Um, what do you think what are going to be some of the blockers to making this successful and actually used out there?
Yeah. Like some of the previous blocker we have is like how to run all the programs inside the ZK WASM because using a ZK WASM is not that easy because we think that the ZK WASM we are using is actually uh, the first ZK WASM. So we encounter a lot of like the new issues about uh, running the custom code inside this ZKVM. And we had some blockers before but right now we can support like all those customized programs running inside of them. And this is one part. And also I think another major part is that how we optimize the performance for the proof generation. Because if we want to efficiently do all those proof generation and also the execution itself, we need to at least fit this proof generation time into 12 seconds, which is the Ethereum block interval, so that we are kind of like having a smaller overhead for this proof generation, and this proof will not be delayed after the next block is mined. So this is also requires a lot of the work, and some future direction is that we can use hardware acceleration, like maybe ASIC for the prover nodes, and maybe also the GPU acceleration for our proof generation process. And also protocol-wise, we maybe uh, like optimize our ZK protocol, optimize our ZK WASM, and maybe adding like new features or new techniques into our Halo 2 framework. And uh, also network-wise, maybe we can separate the proving job into smaller proving jobs to different prover nodes. So those prover nodes can do the proof generation process like at the same time. So this also makes the proof generation time much shorter. So this is like a major part that we want to achieve, is that we want to shorten the proof generation time into 12 seconds.
Nice. Yeah. Well, if you need, we have a long history of working with a bunch of FPGA developers.
Yes, yes,
So
yes.
let me know. Happy to intro.
Yeah, FPGA is also another great part. So recently, I think I see a lot of like ZK hardware war going on,
Yep.
and people are talking about like is FPGA more efficient or ASIC more efficient, or maybe is GPU a nice way to do the ZK hardware or something like that. So I think it's good because people are debating about that, and eventually, I think we will have uh, have some winners in the ZK hardware race, and we can like some sort of like take advantage of that. Like we can have a really good proof generation speed, and this like will make the whole ZK ecosystem much better.
Oh man, if you can bring back hardware wars and like get those blue collar miners back into it from back
Yeah,
in the day, like they would love if like we go back around to needing GPU miners. It would
yeah,
be a
yeah,
wild turn in the space. And then yeah, no, but this was super awesome. Like I know we use the graph and I think like how are you thinking from a business standpoint? Like most people who use the graph, like they if for us like we're running a website, like it's not critical infrastructure, if you will. We pull Ethereum node or an archive node to get all previous event data is like basically free, but it pulls it over, like is there is there like a subset of people that you're going after that like where it needs to be critically secure? Because like right now, I think most people using the graph, it's like basically just to save you the overhead of having to run a full node. Um, what do you think about?
yeah, yeah. So I think it's some of our users or clients will be a subset of the graph's users. Um, but also like I think in general, the users that use our services is the one that value data integrity and also decentralization. I think most of the graphs clients is falls into that part because a lot of the DeFi protocols they are using the graph services, and I think DeFi protocols values the data integrity a lot. Like like half of a year ago is the Uniswap actually have some raw data on their dashboard. So this wasn't taken down after a few months. And I think they are using the graph. So this is really kind of confusing for all those users that checking the Uniswap dashboard website. And also, like recently, we have like some event, some hack that
We're so close to the end.
yeah on their website, and then the user lose like a couple of million when they are making a swap. So this shows how data is a necessary part for the whole decentralized application. And also one of the other advantage we are providing is unstoppable because um, having this ZK node, having this ZK into our mechanism makes the network more alive because you can just run the node anywhere and you don't have the staking model that may be restricted by like the SEC or something like that. So it's more unstoppable. And I think it is a key part of running a middleware network. So these are, yeah. So any uh, protocol builders that want decentralization, security, and unstoppableness, they will eventually use Hyperlocal.
Super cool. Yeah, so to kind of wrap up, where can people find you? You know, what sort of Twitter, website, etc.
And our website is hyperoracle.io. And also we have a Miro page, which we post our research post and also our architecture designs there. It is Miro.xyz and hyperoracle.blog.ease. Yes.
Awesome. No, well, thank you so much for having this. This was awesome. I learned a ton. You were our first, what is it, output oracle on the show. So super exciting to have you.
Yes.
Thanks.
Yes. Thank you for your time.